All right, so today we are going to do a little bit about part studios and doing multiple parts in a part studio. And the good news is that I can show you how you can do all this without even having to watch this video. So I've been trying to stress at the beginning of every one of the Onshape things that I covered that you'll learn so much more and so much more quickly if you do things from the learning pathways. So I'm basically just going to record myself doing one of the learning pathway courses specifically about the part studios. And I would encourage y'all to do more of them besides just the one that I'm doing in this video. So I'll show you that it doesn't take very long, and I'm just going to record myself as I go through it. So here we go. I click the Learning Center up in the top right after I sign in where it says Learning Center here. That opens up a new tab. And you can see here that there's at the top all these different options of things to do. I want to do a self-paced course, the learning pathway. I've created a new account, so I haven't done any of these yet in this Pearland Students account that I made. And so I want to find the Onshape Fundamentals CAD. So the two that I would recommend that y'all do are things from the CAD Basics and things from the Onshape Fundamentals CAD. We're going to do this one today, and I would recommend doing the navigating Onshape and introduction to sketchings and then part design using Part Studios. Today what we're going to do is a multi-part Part Studios one. But there's also good ones on assemblies and drawings. And these are much more thorough than the things that we've already done. So even if you start doing it and you feel like, oh, I kind of know how to do this, this is really going to show you a lot more good information. And it's got step-by-step. So let's go and look at one. So I click the View Details for the multi-part Part Studios. It gives me a course description here, what to expect, course syllabus, etc. I'm going to click Start Course. And here we have the course basically. So there's a page in the middle here that has the details. It has a transcript here if you want to read along while the video is going. I'm going to go ahead and I'm going to play the video, and I'm just going to sit and listen. I'm also even going to full size it for watching it.
Up to this point, all of our parts have been built in isolation, one at a time in separate part studios. This is often referred to as bottom-up design, where each part is modeled in isolation and everything is assembled in the assembly. What we haven't talked about so far is multi-part part studios in Onshape. In Onshape, you can model one part in a part studio, or you can model multiple parts in a part studio. So why would you model multiple parts in a part studio? There are a few different reasons. The first and probably most common example is multi-part modeling allows you to model unique and interrelated parts together quickly and easily. This is often referred to as top-down design. If you look at this cantilever clamp example, I've modeled all the unique and interrelated parts in a single part studio. And in building it this way, I've built in geometric relationships and design intent between parts. If I had modeled these parts in separate part studios, I would be going back and forth a lot, entering dimensions and figuring out values. And if I decided to change my design, I would need to change dimensions in several places. However, if I build all the parts together in the same part studio, I can easily change a single feature or sketch and have many parts update at once. So not only are the parts easier to create, but they behave better when geometry is changed. So building parts in a top-down manner, or multi-part modeling in a single part studio, makes it very easy to build parts with relationships to one another. But there are a couple more use cases where multi-part modeling can be useful. One good example of multi-part modeling would be using a part as a tool to be removed from or merged with a finished part at some point in the future. This is a common technique used in other professional 3D CAD systems that is often referred to as multi-body design. Essentially, you're separating a part, making modifications to that separate part that don't affect any other parts, and later merging or removing that part with another. One good example of this would be splitting your part up to shell it. In this example, I want to shell the handle of the squeegee, but not the transition. Right now, they're currently one part. But I can use the split command to split this into two parts, then shell the part that I want. Because they are two separate parts in my part studio, I can shell one without impacting another. after the shell is complete, I can merge them back into one part with the Boolean command. So that's an example of creating a separate part solely for the purpose of shelling that part separately from the rest and then later merging it back together. There's one more good example of multipart modeling to mention. It's called bridging. Bridging is a common technique where a part is designed initially as two separate parts, but is later joined with a bridge. The squeegee is a good example of this. If we roll back in its design, you can see there was a time in the design where the handle and the base of the squeegee were two separate parts. This is because the handle was modeled first, then the base for the squeegee, and the transition between them was saved for last. It isn't until I create the bridge or feature that joins the two parts that it is merged into one. So with all of this, you may ask yourself a few questions. One may be, what is the difference between this and multi-body modeling I've done in other CAD systems? While there are many similarities, it's important to remember that we are modeling unique parts in the Part Studio, parts that can have metadata, materials, and other information assigned and can easily be inserted into the assembly. The next question that may come up is, what is the difference between a Part Studio and an assembly? It's important to remember a Part Studio is where parts are designed. Assemblies are where we bring together all of our parts, including all of the instances of parts, and we test out any motion in the design. Next up, we'll be discussing multi-part modeling in more detail.
All right, so as you can see, it even gives me an easy button to hit to go to the next lesson. And so, let's see, this is still, I'm confused. Okay, so it showed me applications, then I think we need to watch this one. Okay, I didn't realize that I was duplicating the mic output, and hopefully this is better now. We'll continue on.
Doing top-down design in a multi-part Part Studio can make creating unique and interrelated parts easy. For example, here we're designing a cantilever clamp, and if we switch tabs, you can see that all the parts of this clamp were designed together in a single Part Studio. In fact, all of these parts are driven from a single sketch. So let's take a moment to discuss how this example was created and some of the advantages of designing this way. One of the most important things to remember when doing multi-part part modeling in Onshape is the new Boolean option when creating a feature. So for example, here we've extruded one arm of our cantilever clamp. I want to extrude the second arm, so I show the sketch in the feature list and click the extrude command from the toolbar, then choose the contours of the sketch that represent the second arm. Notice, by default, the Boolean option is set to add this feature to the existing part. This means that by default, my second extrude, my second arm, will be merged with the first. And in most cases, that is the behavior you want. But in this example, we want to create a new part. So we must choose the option for new. Notice a new part has been added to the parts list on the left. It's important to remember those options for new, add, remove, and intersect exist in nearly every Onshape command. So anytime you're ready for a new part in your Part Studio, simply choose new when creating a feature. So now that we have both arms, we want to design the pins for our clamp that will go into the arms. I'll start a sketch on one of the arms and sketch circles for each pin. Then I'll start a second sketch on the second arm and sketch 2 more circles for 2 more pins. So we've created 2 sketches and 4 circles, and we want to extrude them to create 4 pins. All we need to do is select both sketches and click the extrude command from the toolbar. All 4 pins are then extruded in one feature. So you can create new parts by choosing the new option in features. You can create new parts by simply extruding multiple profiles at once. But what are some of the other benefits of multi-part part modeling? One of the biggest benefits is the ability to subtract one part from another. For example, we've created our pins, but you can see they're overlapping with the clamp arms, and we need to create cuts in the pins to allow them to be pressed into the arm. If we had modeled each pin independently, we would need to take measurements from the arm, switch tabs to each pin, and create an individual sketch and feature for each cut. But because these parts are modeled together in the same part studio, we can use the Boolean command and the option to subtract. This allows me to subtract the arms from the pins, creating the perfect contour in each pin and a single feature. The final step in our clamp example is to mirror the pins. I'll select the mirror command, choose part mirror, and select each pin. As mentioned earlier, nearly every command in Onshape has the Boolean options at the top to create new, add, remove, or intersect. And the mirror command is no exception. If I leave this set to new, this will create 4 new parts for each of the mirrored pins. But I want to merge these mirrored parts with the original pins. So I'll choose add and select each pin in my merge scope. This will merge the mirrored pins with the originals. There are a few things to consider when creating multiple parts in a part studio. We'll be covering the best practices of when and when not to create parts together in the same part studio in the future.
Next video.
So now that we've taken some time to understand what multi-part modeling is and some examples where you might use it, let's discuss some bad practices and things to avoid when multi-part modeling in Onshape. One of the first things to avoid is modeling multiple unrelated parts together in the same part studio. Remember, the benefit of modeling multiple parts together is it makes it easy to create relationships between parts. If the part has few or no geometric dependencies to other parts, it's best to model it in a separate part studio. Putting parts together in the same part studio that have no relationship to one another leads to confusion in understanding the feature list and in extreme cases even performance issues. The next thing to avoid is modeling multiple instances of the same part in a part studio. You only want to model unique parts in a single part studio. So for an example, here I have a pneumatic cylinder designed in a single part studio. Notice that it only has one tie rod modeled in the part studio. The finished assembly will have all 4 tie rods, but I'm only modeling one in the part studio. Remember that assemblies in Onshape are important not only for testing motion, but inserting all of the instances of parts to complete the design. We do not want to pattern or create more instances of the tie rod in the part studio. In the part studio, you cannot have multiple instances of the same part. So if I were to pattern the part in the part studio, it would not be seen as one tie rod with a quantity of 4. Instead, the pattern will create 4 independent parts. That is why it's best to save inserting all of the instances of parts for the assembly. In general, this separation of part studio and assembly is done for the sake of performance and also organization of your CAD data. To recap, think of a part studio as a place where your part modeling is done. You can model multiple parts together in the same part studio, but avoid modeling multiple unrelated parts together and avoid modeling the same part multiple times in a part studio.
All right, I'm hitting escape because it's screwing up for going to the next section. So in the next section here is going to be more videos, but then there's going to be an exercise, and so we'll walk through that exercise together.
So now that we've covered briefly some examples of when to and when not to use multi-part modeling, let's take a look at a specific technique you can use to build robust designs in Onshape, the master sketch technique. Think of the master sketch technique as using a single sketch to drive multiple parts in your design. In this example, I'm designing a cantilever clamp with several parts. I want to model all of the unique, interrelated parts together in the same part studio using this sketch. A few things to notice about this sketch. Notice that there are multiple closed contours in one sketch. With Onshape, you can use these contours to create a single part or multiple parts. It's up to you. So you don't have to think in terms of one sketch, one feature. Here I have sketched both arms of my cantilever clamp in the same sketch. If I wanted to extrude the first arm, simply click Extrude and choose the contours associated with that arm from the graphics. It's important to remember that if you choose the sketch from the feature list, it will select everything in the sketch. So now we've extruded the first arm in our example, and we want to extrude the second. One big tip is by default, when a sketch is used by a feature, it is automatically hidden. but you can show the sketch by clicking the eye symbol next to it in the feature list. Now that our sketch is showing, we can create our second extrude for the second arm. So now I'll select the contours for the second arm and set my depth and direction. And here is an important step. By default, you can see the extrude command is set to add, meaning this extrude that I'm currently creating will be added to or merged with another part. You can see the name of the part it will be added to in the merge scope. Now, of course, in our example, I want to create a new second arm, not merge this extrude with our previous arm. So instead of add, I will click new. Notice that as soon as I do this, a new part is added to the parts list. These options are what we call Boolean options, and they include the ability to create new parts, add to existing parts, remove or cut a part or parts, and intersect, which will leave you only what is intersecting between your feature and the part or parts defined in the merge scope. So now that we have two arms, we need to add the pins that join the arms. Remember, the master sketch technique does not necessarily mean only creating and using one sketch. It just means that one sketch is driving everything. So we can create a new sketch, for instance on the face of the top arm, and with the use command, convert a circle from the master sketch into the current sketch. Or we can use the offset command to offset geometry from the master sketch. You can even sketch geometry and add dimensions related to the master sketch. In all of these examples, the master sketch is still driving all of the geometry. We are just creating a new sketch and referencing the original for the sake of creating the pins. I can do this one more time, this time on the face of the bottom arm, and we've created all the sketch geometry we need for the pins. So now we have two sketches on two different planes, and we want to create our pins. Simply click the Extrude command from the toolbar, click on both sketches, and all four pins will be created. Notice 4 new parts in our part studio. So what would be the benefit of modeling this way? Having a design driven from a single sketch means making changes to the design is simple. Because everything is driven from the sketch, a change to this sketch will change the size, position, and orientation of many different parts all at once. So in my example, I can make a simple dimension change, and you can see the size of both arms update, as well as the location of the pins.
All right, so now we have an exercise, and so you can see it's a little bit of a different setup here now. We have these pages here to go next, and then we've got a next slide here. So you'll notice that this is grayed out. You want to go through the slides. If you have 2 monitors, that will be easiest. But if you don't, you can also potentially do something like this, where you've got one tab open on one side of your monitor and one tab on the other. It's a little less convenient, but it'll be okay. All right, so I'm going to signed in, and so it says here, create a new document and be sure that the workspace length unit is set to millimeters. And then we're going to begin a new sketch on the front plane. So new document, I'm going to call it multi-part exercise. And if you've done the navigating on Shape 1, you'll know how to change your units. I'm going to change workspace units to millimeters, and we're going to create a sketch on the front plane. Oops, still there. And I want to rename it to Master Sketch. And then we can go to the next slide. All right, so then sketch the construction lines as shown. Be sure the necessary sketch constraints are added. This includes an equal constraint between the 3 indicated lines, a midpoint constraint. We'll work through this together here. So I'm going to come over here and hit N to make the front, and I want to do line, and if you recall, we talked about the construction lines. I'm going to kind of just draw them initially without any particular constraints, and then we'll come through and add other ones. Oh, whoops. This one's wrong, so I'll do line L and Q. This is supposed to come through here. Let's see. Got to show constraints. This isn't supposed to be perpendicular, so I'm going to delete that. And then I think this line is horizontal, so I do need a line here that is horizontal. All right. So we want to make some constraints here. So we want perpendicular between these two lines. And is that it? I think that's the only one. And then we want equal. So let's go make these three lines equal, 1, and then this and this will be equal. We need to make a midpoint. So pre-select the sketch entity and then select the midpoint constraint. So I want to go here, pre-select it, then midpoint. You know what, I think I need to have a point on here. So I've got the point and the line. Let's do midpoint, there we go. So now that point is on the line, and this probably needs to be coincident there. Okay. And then we need to have 2 points that are symmetric about the horizontal line. So let's go find the symmetric. And so it says, let's look at the instructions here. Pre-select a line or linear edge and 2 other geometries of the same type, and then click it. So we'll pre-select the line and then these 2 points, and then we'll click symmetric. There we go. Okay, so I've got the midpoint, they're equal, they're symmetric, the line's horizontal. Is there anything else? All right, that's it. Next slide. Sketch the circles as shown. All the circles labeled A are equal in diameter and separately. All circles labeled B are equal in diameter, and then add the necessary sketch constraints to make these 2 sets of circles equal. All right, so we're going to have a couple of different things here. So let's create some center point circles. We want one here, 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 basically every one of these lines, or every one of those points. Okay, and so let's go make all of those equal. So again, if you hover it over it, you can pre-select the sketch entities and then select the equal constraint. So I'm going to select these circles. If you haven't taken the other Onshape courses, just as a reminder, if you're confused about how to select something or deselect things, you can hit spacebar and it clears everything that's selected. I'm not hitting any additional keys to be able to select multiple things. You don't have to hold control or anything like that. So I'm just selecting those circles, and then I'm going to go and make them all equal. And then I'm going to make this, let's see, let's make this coincident with the, there we go. That way maybe we can move this some, whatever, that's fine. And I want to make some more circles here that are going to be bigger. And these constraints are starting to get a little annoying to see because there's so many coincidences there. So I'm going to uncheck that to hide those, and let's select the big circles now. Again. And we will make those equal again. All right. Add the necessary sketch constraints to make those equal. So I think I've got all the A and B circles. So we'll continue on. Add the dimensions shown in the image with the dimension tool. Start with, and it suggests starting with the 175 dimension. So I'm going to hit the D key, D for dimension, and I'll make this 175 millimeters. And then we want to make this one 75 millimeters. And then we want this circle here to be 50. Oop, that looks like I did something wrong with one of these constraints. Let's go back to the previous slide. Oh, this one's not supposed to be equal. So I'm going to highlight the equal sign and delete it. So now this one hopefully can get bigger without impacting the others. Oh, hang on. There we go. And I accidentally removed the equal constraint from the smaller one, so we'll redo that. Okay. So now I can do D for dimension. We'll make this one 50. Go to the next slide, and we'll do 10 for the smaller one and 25 for this larger one. So that should be all the dimensions. Okay. Then it says create the sketch geometry for the large arm by sketching lines tangent to the circles. Be sure that all lines are tangent at every vertex connecting to the circle. The two vertices indicated are horizontal to each other. So, so it's saying that those two are horizontal. Okay. And we'll just hit L for the line over here, and I'm going to select here, and if you hover over it, you can see you can either make it coincident, or when you get to a certain point, it makes it tangent. So I'm going to make that tangent, and I'm going to hit escape because right now it's still trying to draw a line, and I don't want that. And I'm just going to grab a point here and make this tangent. This just comes over here. It doesn't go anywhere in particular. This one needs to be tangent. And then do the same thing here where going from here. Oh, this isn't connected to that. Undo. Let's delete this line and try again. Oh, I see. I'm not connecting it to the right thing. There we go. Okay. Also, I'm concerned this looks like the circles are wrong. Did I get that dimension right? We've got 10 for the inside and 25 for the outside. Yeah. 75, 175, 50. Okay. All right, so let's go ahead and make some things tangent. So I'm going to select the tangent, and let's go here and here, and then I'm going to click this line on the circle, and we'll make sure that these are tangent, and this is tangent. Basically, while the tangent thing is selected, it doesn't like something. Oh, it's because it's got a coincident constraint here. Let's delete that. If you don't know, you can always try deleting that line, come over here, and then you can see that it's trying to make this line horizontal with the origin. See how the origin is orange? That's no good. So we're going to put it somewhere else, and then we can come back to the tangent, select the line, and then the circle, and the same thing down here. And then it also made a point that two were horizontal with each other, so we'll make those be horizontal. And I think that's everything here. Next slide. So add a parallel sketch constraint between the indicated lines. So we want to make sure that we're going to do parallel, and we want this and this to be parallel. And then add a tangent sketch constraint between the indicated line and circle. So we're going to make it so that even though the line and circle aren't touching, we want it to be constrained such that it would be tangent if it extended. Okay. And then we want to do basically a similar thing down here of adding these tangent lines. So I'm going to do L for line. I'll just make these and I'll go make them tangent in a little bit. I'm sure that there's a way to make it so I don't have to escape, and it's been a while since I've done it, so I don't remember how right now. Oh. All right, and then tangent. Oh, actually, I don't want these to be, I don't want that there. I'm going to delete the tangent constraint. Actually, I'll just delete these lines. And I'll go line from here to here to here. So let's make them tangent. Next slide. All right, we want to add a parallel sketch constraint between the indicated lines, so just like before. We'll make these two things parallel. And then we want to make a tangent constraint like before, so tangent between here and here. And then we're going to create a sketch fillet at the two sharp vertices as shown. So here and here, we're going to use a fillet. And so the dimension should be R15, so that's a radius of 15. So let's look for our, is this the fillet here? Sketch fillet. So we'll select these two lines, and then these two lines, and we can either drag it, but I'm just going to type into it there, 15. And then we're going to sketch 4 additional circles that should be equal to each other, and these will be used to create the pin. So we're going to create circles here, 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 and here. And then I want to go and make them equal. So these to all be equal. I probably should have just selected all 4 of them and then hit the equal just once. Also, just because it's kind of bugging me, I'm going to drag this and make that coincident there so that these are black lines now. Okay, ooh, that's interesting. Oh, this also helped because now I found something that wasn't fully defined. This wasn't tangent over here. There we go. Add the final dimension of 15 millimeters for the circles added on the last step. Be sure that your sketch is fully defined before moving on to the next step. It's fully defined now that I put the center at the origin. If you have blue lines here, you might just grab something, one of the center points of the circles, and moving it to the origin. So it's fully defined. I'm going to hit the check mark to accept it. And then go to the next slide. To validate your sketch, select the 3 regions shown and note the area in the bottom right. Continue to the next page. So if I go here and I select this area, and this area, and I click the, let's see, show measure details, I've got 8031.195. So we'll go to the next page. 8301.195. That's the one that we want. See results. And we're correct. So we'll continue on to the next section. And I'm going to maximize this and watch these videos
One of the
now.
unique things about Onshape's Multipart Part Studio is that you can create a single feature that impacts multiple parts. There are many examples where you might want a single feature to impact multiple parts, so let's take a look. In this example, I've designed a pneumatic cylinder in a single Part Studio. Now I want to create holes for the tie rods in both end caps. If I select my sketch and choose Extrude then Remove, you can see the holes in the first part are created. You can see that part's name listed in the merge scope of the Extrude command. This means I can choose an end condition like through all, and the command will still only impact the part listed in the merge scope. If I wanted this feature to cut through multiple parts, simply add them to the merge scope. To do this, click in the merge scope, then click on the part that you want to add to the merge scope. You can see this cut is now going through both end caps in this Part Studio. This is one of the biggest advantages of multi-part modeling. Instead of going back and forth between tabs, taking measurements and entering dimensions, I can create a single feature that cuts both parts because it was all modeled together in the same Part Studio. But this isn't specific to Extrude Remove. You can define the merge scope of almost any feature. Extrudes, revolves, sweeps, lofts, and other commands have this ability to define what parts are affected by this feature. Another common example is fillets and chamfers. In Onshape, you can fillet or chamfer several parts with a single feature. Simply select the fillet or chamfer command and select entities to fillet or chamfer. It doesn't matter if they're on the same part or not. The nice thing about this approach is you can change the size of fillets of many parts at once. The last example to give is using the hole feature. In fact, the hole feature has some particularly neat functionality when it comes to multi-part holes. In this example, I have a seal retainer that is bolted to an end cap. I want a counter bore in the seal retainer and a blind hole in the end cap. If these were modeled separately, I would need to create a separate hole in each part, but because they're modeled together in the same Part Studio, I can use the hole feature to accomplish this. Simply click the hole feature from the toolbar, select my hole type and size, and click on a point. Then in my merge scope, I will make sure both parts that I want to create a hole in are selected. You can see if I section view that the hole goes through both parts. The hole feature also has an option for blind in last. As the name implies, this will make it a blind hole in the last part in your merge scope. This becomes really useful in examples like this where I want a counterbore and clearance through one part and a tapped hole in another. So to recap, a single feature in Onshape can impact multiple parts. A feature in Onshape doesn't care if it's applied to one part or many, and you have the flexibility to choose what parts are impacted by your feature.
Next
Features
video.
can be used to create multiple parts within a single part studio. After a while, you may have several features within a single part studio, making it difficult to remember which features construct each part within the part studio. This video covers both feature filtering and feature folder functionality available within a feature list. At the top of the features list is the ability to search through the list by using filters. This includes filtering by part, type, name, folder, and variable. Click the filter icon and select one of the filters. It automatically inputs into the search box. You can also manually type in the filter you want to use by typing in a colon followed by the filter option. After the filter is applied, type in the search criteria you are looking for within that filter. In this example, filter by the type of feature and search for all existing extrude features. Filter by :type and input extrude, and all existing extrude features appear. To look for features associated with a specific part, filter by using :part and type in the name of the part. The results show all features that contribute to that filtered part. In addition, you can also filter by :all parts. This filters for features that are associated with all the parts within the Part Studio. You can edit any feature that appears like you normally would by double-clicking or right-clicking and selecting Edit. The ellipses that appears indicates other features. Hover over one to reveal the filtered out features. Filtering through features is helpful when you want to find a particular feature but you can also organize features with feature folders. Folders can be used to group features together for certain parts, to group common features across multiple parts, or to simply organize the feature list. Let's go into how to use feature folders in a Part Studio. To create a folder in the features list, select the items you want to organize together, right-click, and select Add Selection to Folder. The folder name dialog appears. Type in a name, and accept a new folder. The new folder is created with the name given. You see in parentheses the number of total features within that folder. Click the caret to open the folder to reveal the features within that folder. You can also create folders using the folder icon located at the top of the features list. Click on the folder icon, enter a name, and accept a new folder. You can click and drag features into the folder. You can also remove features from folders. If you want to unpack a folder, right-click on the feature and select Unpack Folder. This does not delete the features within the folder. If you want to delete a folder, click Delete. This action deletes all the features within that folder and the folder. One thing to note, when creating folders within the feature list, is the features and folders are order dependent. Features still need to be organized in the correct solve order to keep the parent-child relationship between them intact. Moving folders could result in features erroring if a folder with child features is moved above the parent feature. When creating features in a Part Studio, you can filter and organize a feature list to help with organization and understanding how features contribute to the design.
Not gonna lie, that was an important lesson for me. I didn't know that that was stuff. I completely forgot about it.
Now, let's discuss some tips for working with multi-part part studios in Onshape. After you've created a few parts in your part studio, there are a few useful tips that can make working with them easier. The first tip is the parts you create will be listed in the order they were created in the parts list just below the feature list. If you want to rename a part, simply right-click the part in the parts list and choose Rename. If you want to see which part is which, simply left-click the part and it will highlight in the graphics. You can hide or show a part by clicking the eye next to the part's name in the parts list. You can also right-click on the part in the parts list to hide. In the right-click menu, you have a few additional hide options. They are Hide Other Parts and Hide All Parts. As the names imply, Hide Other Parts will hide everything except for the part you've selected. A great way to hide everything but the part you want to work on. And Hide All Parts will hide all parts. You can find these same right-click menu options when right-clicking on a part in the graphics. If you have parts hidden and you right-click in the empty graphic space, you'll see an option to show all parts.
All right, last one before the last exercise here.
The Isolate tool changes the view of parts in the Multipart Part Studio by changing the display style of the selected parts. This helps visually understand the location of the selected parts within the Part Studio. The parts that you are not working with are shown in a transparent style, allowing you to see the parts you are working with for context. This video explains how to use the Isolate functionality when working with multiple parts in a single Part Studio. You can also use Isolate within an Assembly tab, and that is explained in the Onshape Assemblies course. To use Isolate, select a part or parts to isolate in a parts list or graphics area. Right-click and choose Isolate in the context menu. The Isolate dialog appears. Only the distance option is applicable when working in a Part Studio. Both distance and connectivity options are available when isolating instances in an assembly. Isolating by distance expands the isolated parts based on their proximity to the selected parts. Moving the slider one way isolates more parts, and the other way narrows the isolation to just the selection. Isolate makes the unselected parts transparent. While in this mode, you can click through the transparent parts. You can only click on the isolated parts. This tool helps you visualize how the parts in a Part Studio are geometrically and spatially related to one another for context, while allowing you to easily click and make changes to the isolated parts. To exit the Isolate command, click on the X in the Isolate dialog, open the context menu and select Exit Isolate, or simply use the Escape key. Isolate helps you work on the selected parts while contextualizing how those parts are related to one another in a single part studio.
Okay. All right, we are going to open the public document here. So if I do this, it opens in a new tab. I'm going to bring that to the side like we just did before. Select the document menu and select copy workspace. All right, next slide. Extrude the closed contours of the master sketch indicated to a depth of 5 millimeter. Be sure the extrusion direction matches the image. All right, so we want to do extrude, and we're going to extrude, let's see, all of these. And looks like internal as well. These little holes. Okay. And it's supposed to be 5 millimeters. And the extrude direction matches that arrow. And then it says rename the part in the parts list part 1. So we're going to hit accept here. And we're going to rename this large arm. But do not select the smallest circles in the master sketch. And so the smallest circles are those. Oh, and I missed something here. So let's double click this and let's add these contours in here. Okay, there we go. Now we need to show the master sketch. It looks like it's still being shown, so that's okay. To extrude the small arm, create another extrude feature and select the indicated closed contours of the master sketch. Extrude the small arm to a depth of 5 millimeters in the opposite direction of the large arm. So we're going to come over here and extrude. I'm going to go ahead and get these guys. And we want to flip it around the other way. And we want to do this as a new part. And 5 millimeters. Looks right to me. Then we're going to rename this small arm. Next, we need to create 2 sketches for the grips. We want to be sure the grip sketches are related to the master sketch. So we're going to insert a new sketch on the face of the large arm. So we'll go sketch, select the large arm, and then we're going to hide the master sketch by clicking this eyeball so that it's less confusing. And I'll even go ahead and rename this like it suggests a large arm grip sketch. Sketch the entity shown using the rectangle line, use and construction sketch tools. To create the circle in the sketch, project the edge of the hole in the large arm with the use command, add all dimensions shown. All right, so where are we at here? It looks like we're down here at the bottom. So I'm going to zoom in down here. And we want, looks like a rectangle over here. And we want to, let's see, it said, to create the circle in the sketch, project the edge of the hole in the large arm. So we want to select this and right-click Use. And then we want to set a dimension here of center line in the master sketch. We will want to be able to see this, I guess. Oh, whoops. I am drawing it in the wrong place. Looks like I actually want to, let's just X out of here. And I'm wondering if I did it on the wrong side. Let's come back over here. And let's do a sketch over here. Oh, and we don't want it on the face of the master sketch. We want it on the face of the large arm. There we go. And we'll create a box. Dang it, keep hitting the wrong one. Gonna hit the U key to use that circle. D for dimension to make this 1 millimeter from the center line. Let's go back over here. And then we want okay, so we need to create a construction line in the center here. Whoops. L for line, Q for construction. I'm going to put it at the midpoint. You can see that there's a square that pops up. That means that I'm right in the midpoint there. I'm going to come up here, and then I want two non-construction lines that are going from here and here. And let's make these equal. And then need a dimension from here to here. Makes this 10. Is this no longer in the midpoint? I see. The sides of the rectangle are equal, so we'll make these two things equal. I'm going to make this a little bit wider here. The center of the square is coincident to the center of the hole, so let's see. How do we get the center? You know what, I'm going to change to using a different type of square. Let's do that. So I'm going to delete these things. We'll just delete all this. I'm going to create the center point rectangle. And we want to go D1. And then we want to make sure that these are equal. And then we need our construction line in the center. Then our non-construction lines over here. And make this be 10. Two sides of the triangle are equal. Construction line is vertical. The endpoint of the construction line is the midpoint of the square's bottom line. Oh, and it's supposed to be 10. Millimeters tall. All right, and then we'll accept this. Next slide. Create a new sketch on the indicated face of the small arm. So looks like that's in the same spot here. So we'll create a sketch on, I'm going to hide this real quick to put it on the small arm. And we'll rename this to Small Arm Grip Sketch. And we can unhide the master sketch to create the circle in the sketch, project the line at the edge of the hole. So we'll select that and use. Be sure to add the following sketch constraints. The center line of the square is coincident to the center of the hole, so we'll use this guy again. And then be sure the sides of the square are equal to the sides of the square in the large grip. So we can do this and make sure that they're all equal. construction line and the large arm grip sketch. Oh, yeah, so we're making the triangle again, and it's going to be equal. So we'll put this guy in the center again. So if we make this equal, and the endpoint of the construction line is the midpoint of the square's top horizontal line, the lines of the triangle are equal. Okay, still missing something about how to make sure that these are in the right spot. So let's see what it wants us to do. Okay, well, it doesn't tell us, but I think we should be able to do it by making sure that they are vertical, since they are otherwise equal. So if we do that, they're all done. And I'm going to open up this one to rename the sketch to large arm grip sketch. Okay, so next thing it says, create a reference plane that is offset 25 millimeters from the indicated face of the large arm. So we are going to come up here, and we've got a plane. We're going to do it off of the large arm. And it's offset 25 millimeters. Perfect. So that's all we need. Oh, actually, I did it on the wrong side. Let's delete that plane. Let's go back and see. So yeah, we need to be looking at it like this. We can do this again, though. Offset 25 millimeters. Okay. So you can see that there's a plane now that's offset. Rename it to midplane. Next, we're going to use the master sketch to create 3 different pins. To model the pivot pin on the long arm, create a new extrude. Select the medium circles as extrusion profiles, as shown in the front view. So we're going to click front. And I hope, yeah, that's correct. So we're going to extrude from the master sketch the, let's see. Oh, I wonder if it's actually not the master sketch, but the, oh, I guess it does. Did I miss something? So these aren't construction lines here. Oh, you know what? Let's go back to our extrude here. I bet that these things are, no? If I come over here though, we can use them. Okay, so we're gonna select these medium ones. Going to do new. And we need to do up to face. And we're going to select the mid plane and second end position. We're going to check that, do up to face and face of extrude 1. need to change. Man, I'm getting mixed up here. Let's take a look at this a little bit bigger. So from the front view, oh, it says 2 of the pins can be created using the same extrude. Let's also go back a second and make sure, yeah, that's all good. Okay. Okay, so what we're doing here is I'm going to hide the small arm again, and we're going to do an extrude with the master sketch. And so I'm going to select the medium holes here. I need to hide these sketches. Okay, so I actually want this to come out this way. And then we want a up to face mid plane, and then a second end position that is up to face and here. I'm not sure why it shows 3 things here. Are we supposed to be selecting these guys here too? Hang on. Let's try it again. I'm obviously having difficulties. Oh, you know what? It is supposed to go that way, and then we are supposed to go up to face and then mid plane. There we go. So now that is coming through, right? And then the second end position, we're going up to face, and then that's just going to go to this face. And we might need to, oh. Is it really because I'm supposed to be, I think I've got the mid plane on the wrong side here. So I think that will be okay. Let's come over to, yeah, I do have the mid plane on the wrong side. So let's select this, and we're going to edit it. I'm going to do it off of here, 25 millimeters. And then when I come extrude, I can hide the mid plane, hide these other sketches, select that part, and that part, up to face, mid plane, up to face, here, and new. Okay, sorry that took so long. That was definitely longer than it should have for me, but just goes to show that even I'll struggle sometimes. So let's see where we're at here. Rename the 2 parts pivot pin and large arm pin. Yeah, so it says to hide the arms, be sure to show the large arm selected at the indicated face for the up position. So we'll unhide that now. And then see, I think this is supposed to be the pivot pin, and then this yellow one here is the large arm pin. And then to model the third pin, create a new extrude feature, select the medium circles as extrusion profiles as shown, and be sure the new one is chosen. The small arm pin only needs to extrude in one direction. So we're going to come over here, and we're going to extrude, and we need to extrude this guy, except in the other direction. And then up to midplane and new. But I also noticed that it has the internals, so let's go back and make sure that I've got everything I should. The pins interfere with the two arms. To remove the interferences, we'll use the Boolean feature to subtract the pins from the arms. Select the Boolean feature, so that's this guy here, and choose the subtract option. Click on the large and small arms to use as the tools, and then we're going to select the targets as being these three pins. And then we need to keep the tools. Finally, we're creating the grips. So to model the grips, create a new extrude feature and select the feature or regions shown from the large arm grip sketch. So let's unhide that. Going to extrude. And this is going to be new. And we're going up to face, midplane, oh, I missed the small arm pin. And I think actually we were supposed to do both of these here. Next slide. To complete the large arm grip, create another extrude feature and choose the circle profile from the large arm grip sketch. So I'm going to do another extrude, and we'll hide other things so that it's not confusing. All right, so from the large arm sketch, actually I'm even going to hide the large arm grip. Up to the face of the large arm. So we're going to go up to face, and then we want to merge with the large arm grip. Doesn't like that. Let's exit this real quick. Oh, I think we're not supposed to have those circles. Let's fix that. now I need to extrude from the large arm grip up to face here, and we're going to add merge scope large arm grip. Then I suspect we'll do the same thing over here. So we are going to do it, let's see, on the small arm grip sketch. So just a circle up to face. And we need to be doing add merge with the small arm grip. Okay. So now select the mirror feature and choose part mirror as a mirror type. Be sure add is chosen to add the mirrored parts together. So what we want to do now is find our mirror. And we're going to do part mirror and add, we're going to select these parts. And then the mirror plane, we're going to select the mid plane. Oh, actually, yeah. And then hit accept. And now our parts look like that. Yep, sure does. And we're going to add a couple of few details. So we're going to fillet the 10 edges of the grips. So we can come over here and do the fillet and look at the grips. And so it says 10 edges. So we're going to do 1, 2, 3, 4, 5, 6. You want to be sure to get the edges, not the face. 10 or 8. And then we want this line and this line, and it's going to be a 2 millimeter. I don't know what that is. Okay. Select all the parts. Right click and assign material, and we're going to use aluminum 1060. So we'll search here, aluminum 1060. So recap, you can read this, I would recommend it, just making sure there's nothing I need to talk about here. Okay, and then now it's showing us the benefit of doing the master sketch. So we're going to make some design changes to understand all of that. So we're going to edit the master sketch and change all the dimensions as shown. So if I come here and open up the master sketch. Okay, so let's look at this. We need to change this to be 300 and this to be 125. And we'll change this big guy to be 75. This one to be 25. Change this radius to be 20. These guys to be 15. And these guys to be 45. All right, so that looks like it. We'll hit accept. And you can see that everything auto-updated to still be exactly right. So that is why it's such a big deal to be able to do that. Edit the main mid-plane feature and increase the offset by 35 millimeters, or to 35 millimeters rather. And then this is just another recap. We're going to select all the parts from the parts list. and then hit this mass icon here. Hopefully I did everything right. And what is the mass? Uh-oh, 1.82. I did something wrong. Womp womp. Okay, well, what I would do now is go back and try to figure out where it is that I may have done something wrong. My suspicion is that where it is that I had some problems earlier, I may have done something wrong. So let's take a look and see if I can figure out anything though. This is suspicious right now that these should be, oh no, it's because that's on the inside. Does that make sense? Okay, so let's roll back here. So when we're here, extrude. Well, I hope I was in the right direction here. That might be it. Anyway, hopefully you have more luck than me. I'm going to go ahead and stop the video here though, and hopefully you learn a little bit about Part Studios.